Before the beginning, the eye as a camera. The eye can be thought of as being the first camera. The two have many similarities and some big differences. Lenses, light capturing arrays, and apertures, among other things, are shared by both, but the main difference between the two is probably output. With a camera, especially a digital camera, we have many options of how we can view our images. With the eye, what we see is really a nerve impulse translated into images by the brain, where it is stored as memory, so no hard copy. Although, in recent years, researchers have succeeded in decoding and reconstructing those nerve impulses into images, but they have a long way to go, as you will see later. In this section, we will look at the 5 greatest similarities shared by the eye and the camera: lenses, light-proof containers, apertures, sensors, and processors. The lens. The lens allows the eye to focus on objects at various distances, both near and far. Muscles attached to the lens shape it so the light rays entering through the pupil always project a sharp image on the retina. If it doesn't, that is why we wear glasses. The adjustment of the lens so we can focus on objects both near and far is called accommodation. Accommodation is similar to the focusing of a camera by adjusting the lens setting. The camera lens is an optical lens used with a camera body to make images of the real world on film or digital media. The lens is necessary to project a sharp image on the light capturing material or device. A lens may be permanently fixed to a camera, or it may be interchangeable with lenses of different focal lengths, apertures, and other properties. The quality of the lens can make a huge difference in the detail and sharpness of the final image. The light-proof container. While this may seem obvious, both the camera and the eye are light-proof containers, other than the small opening needed for capturing the image. It is vital for the projection of the object being seen, or the object being taken a photograph of, that it be done in a light-proof environment. The smallest amount of light leaking in would decrease the sharpness of the projection and corrupt the quality of the final image. The iris. The iris is a thin, circular structure in the eye responsible for controlling the size of the pupils and therefore the amount of light reaching the retina. In response to the amount of light hitting the eye, muscles attached to the iris expand or contract. At the center of the iris is an opening called the pupil. As everyone knows, when you go from a dark room to the outside, your pupil gets smaller or contracts. And when you enter a dark room, you have to wait for your eyes to adjust. The pupil needs to get larger or dilate to let more light in so you can see. The camera has essentially the same device. In the camera, it is called the aperture or the diaphragm. The most important part of taking a good photograph is controlling how much light enters the camera. The aperture works the same way the iris does. It can be adjusted smaller to let less light in or larger to let more light in. When you take a photo in a dark setting, you set a large aperture opening to let more light in. On a very bright sunny day, you need to set a smaller opening. The size of the aperture opening is called the f-stop. The retina. The retina is a light-sensitive layer of tissue lining the inner surface of the eye. The lens of the eye projects an image of the visual world onto the retina. Light striking the retina initiates a cascade of events that ultimately trigger nerve impulses. These impulses are sent to the brain through the optic nerve. The retina contains light-sensitive photoreceptor cells. There are mainly 2 types, the rods and the cones. The rods function primarily in dim light and provide black and white vision, while the cones support daytime vision and the perception of color. In the camera, a light-sensitive array made of capacitors is used. The capacitors allow the conversion of something called incoming photons into electron charges. The definition of photons is way beyond the scope of this class and was first defined by Albert Einstein. The important thing for us to know is that there is one capacitor for each pixel in the final image. The CCD, or charge-coupled device, then reads out the charges created by the photons. The entire array is read line by line and converted into voltages. The processor. In the eye, the electrical impulses generated by the rods and cones in the retina are sent to the primary visual cortex in the brain via the optic nerve. This area of the brain is responsible for processing visual information, and so we are able to see. The voltages generated by the CCD device are then sampled, digitized, and stored in memory. Firmware in the camera, or a software program such as Adobe Camera Raw, which we will use in this class, interpret and manipulate the raw data from the CCD device to create the image. To recap, there are 5 very clear similarities between the camera and the eye: the lens, light-proof containers, the iris and the aperture, light-sensitive arrays, and processors. And finally, the following images were created by recording the brain's blood flow through the visual cortex and filtering the data in a computer program to recreate an image. In other words, a visual photograph direct from the brain.